speaking of Napoleon, okay, he was a genius when it comes to designing the movement of people, meaning the troops on land. That's where the movement is. The battle is a short-lived event. And he has, I may have told you, he said that an army marches on its belly, meaning on the food. Food has to be available. And so it is the same with lodging. Lodging, where the troops would sleep from stop to stop. And lodging as a need for, in this case, military movement, is the origin of the word logistics. So logistics comes from military engineering, not from logic, or some other word you learn in philosophy. So logistics, S curve. The word was invented in the mid-1800s or earlier, but the so-called observation and the history of it, all the way to predicting it, which is what I contributed, is very recent. But before there was the theory, before that, the literature is about the existing observation that anything that spreads, some would say anything that grows, and that growing thing could be the population of people who read one of my published articles, or the population of those who click on one news item today on whatever source you frequent. That number grows in time, slow, from fast to faster, and then slow again. This is time. And this curve has this shape, and it is universal. You cannot defeat it. Anything that appears or strikes you as viral, meaning accelerating, as if forever, this portion, and by the way, many people all over the place, it's not just in biology and politics and all that, they refer to this early portion as exponential growth. Well, I encourage you to start laughing when you hear that, because the exponential is a special mathematical object, meaning a function that here's the let's call this t here, and so if you plot the function e to t, this is the exponential. The exponential starts rising above 0 at minus infinity. And it keeps going upward and more steeply forever. That's the exponential. The exponential has a finite value at time t equals 0. Another way to laugh is to say nothing in nature starts from minus infinity. Minus infinity is a long time before the Big Bang. Forget it. These people who say exponential forgot their mathematics, meaning from high school, not from Duke University. Okay, so what kind of curve this one is, that's another thing that I'll show you very soon. is the same with the rate at which things are collected. For example, grain from a particular piece of land is collected first faster, faster, and then fastest, and then less and less fast, like this, until all the grain is collected and put in sacks at one collection point. How to predict this? Well, so the model is a two-dimensional conduction, so that's two-dimensional conduction model. This is a square place with a square with the dimension 2 times L1. You'll see why it's 2 times L1. This is a conducting body of temperature T0. And entering from the left, meaning intruding, or if you want, invading from the left, is a blade of a higher temperature called T0 plus delta T. And this blade penetrates with a speed V. As it does, because this square has the conductivity K, as this blade invades, it heats the space by conduction in boundary layer fashion. In other words, the conducting medium feels heated as a finger of thickness little delta. Little delta, you were taught this in heat transfer, but also in fluid mechanics, is the boundary layer thickness. Okay? And using your imagination, you will see this finger growing to the right and getting slightly thicker until its length, which at a particular point in time is L times L as a function of time, that length becomes equal to 2L1. So anyway, so that's the model. So the time of invasion from entrance to hitting the wall, time of invasion is L, well, obviously I just wrote 2L1 over V. The time of transversal heat diffusion, I had this on the board many times, is square root of alpha T, where alpha is the thermal diffusivity, which is K divided by rho, and then the specific heat of the solid. And so that's one thing that we write. This is equation number 1, equation number 2. And then finally, the area over this heating has spread. So we're now calculating the rate of spreading. So this entire area that grows in time, I call it A finger. Which is this length as a function of time. And then delta itself. The fact that there are two deltas doesn't matter because I'm doing scale analysis, so I'm neglecting factor of like 2. And then putting everything together leads to the formula that A finger increases in time as L, this L, to power 3 halves, and then square root of alpha over v, and then all of that after you replace L with the fact that obviously L is V times T, you get that area finger as a function of time goes as T to power 3 halves, and then V to 3 halves, and then square root of alpha over V. And then this can be non-dimensionalized with respect to the total area of invasion, which happens at time t invasion. Where did I write it? Here, this time. And then that means the t invasion here to 3 half, and then the rest is the same. And you find that this ratio of area as a function of time divided by the area at the end of invasion, or if you want to call it intrusion, it's up to you, varies as, meaning actually turns out to be the same as t over the time of invasion, this time, to power 3 halves. And noteworthy is the fact that the exponent is greater than 1. Here's a little graph of from 0 to 1 of the area of the finger versus time divided by the total area at the end of finger invasion. And then on the abscissa is time increasing from 0 to the invasion time, which is here. Call it t invasion. And the exponent, which is greater than 1, means that the curve is convex. See that? So that's half of the battle won. What about after invasion? After invasion, in fact, I'm going to start modeling here. After invasion, the hot intrusion is on the equator, and it's, of course, warmer than the rest of the body. And so that means that heat is conducted vertically farther and farther from the equator to a delta, the same delta as before, alpha square root of alpha t. And so there is an end to this vertical spreading of heating. That is, the end is when this delta becomes the same as L1. Remember, I have L1 here and L1 here. And this process of filling in with heating, the space that was not touched by the finger is called consolidation. I chose these words, invasion and consolidation, from my little knowledge of military history. Every invasion in the history, all the way to contemporary events, happens this way: a fast march and whatever battle conquest to the objective that could be the command post and so on. And then after that is nullified, the invading, it's obviously a group, an army, spreads in the perpendicular direction to let's call it, to solidify the change. And so the time of consolidation is growing, is obviously proportionally with square root of time. And the time of consolidation refers to a delta. So delta consolidation is L1. This is wrong here. L1 does not depend on time. So the time of consolidation is times alpha, and then power 1, 2 is L1. And which means that I write it this way, L1 squared over alpha. And the obviously the total consolidated area is 2L1 squared. And this area that I have to, before we get to this one, the area that grows vertically this way, away from the equator, is 2L1, and then delta is a function of time. So with these ingredients, we can evaluate the area that grows vertically, meaning I'll write it over here. Versus time divided by the final area that's heated, and one gets, after all these ingredients, time divided by the consolidation time to power 1/2. So there's a time of consolidation which is subsequent to the time of invasion, and obviously a greater area called this one at the bottom. So area over total area of the square, and exponent 1/2, which is less than 1, indicates a concave curve, a curve that's shaped this way. So with this analysis, I cracked the nut of this so-called S curve to predict it by, once again, by imagining the asymptotes early on versus late enough. And what happens in the middle, of course, is easy to hand wave away. It's the splicing of these two arcs in a way that has to look this way. So that's the S curve predicted, and has to do with these two forms of filling a territory. First is fast and long through this blade-like invasion, and then short and slow, which is transversely. Yeah. Ask me how I got this idea that the S curve should be easy to predict. I assume you asked me because I'm going to tell you anyway. I was raised under communism, where everything about the war was a lie. The education, which was dictated by obviously a regime installed by the USSR, was that the USSR won the second war alone. You know, the great army. Okay. So here I am in America, and I noticed on television you could actually see every once in a while um, black and white newsreels that were made in Hollywood maybe during the war. And one of them was about the German invasion of France, which was a blitzkrieg. It was just as in my model. It was on a highway. They invaded with their military trucks and tanks on the highway because the Maginot Line was bypassed through Belgium. The French had fortified their eastern frontier in the aftermath of the First War to avoid any further attacks from the Germans. And the Germans said, "Thank you very much." They marched through the farm fields of Belgium and entered from the north, and they got on the highway. And on the highway, they did exactly what I sketched. I did exactly what they did in this movie. They simply drove. They drove to Paris. And as they drove, obviously at the normal speed, behind them, there were other military trucks that were then proceeding transversally, insulating the invasion channel from possible attacks from French army from the sides. So they were doing the consolidating of the invasion. A very simple drawing that was available to my eyes as a movie. Get it? Turns out that is the way things happen in everything that spread, including the rainwater that falls on the ground and then forms a rivulet, the rainwater. And then the rivulet, after that, diffuses laterally and transforms the patch of land into mud or swamp. See that? Same thing. Important to keep in mind.